Welcome to this explainer. Today we're doing something really exciting. We are completely demystifying modern AI. We're going to skip all that overwhelming technical jargon and look at exactly what's going on under the hood entirely in plain English. Okay, let's dive right in.
So let's start with the question I know we've all probably wondered at some point. What actually happens when you type a prompt into an AI and hit send? Like, is there a little brain in there? Is it just searching some massive hidden database of pre-written answers?
Well, to answer that, we kind of need to define what AI even means today. We're mostly talking about machine learning and large language models, or LLMs. But the absolutely crucial thing to understand here is what these models are not. They aren't hand-coded rule systems. Instead, they are statistical pattern recognizers that have digested just enormous amounts of data. Think about this massive shift like this. On one hand, you have the old way of explicit programming. Engineers literally telling a machine, hey, if X happens, then do Y. But on the other hand, we have pattern recognition. Engineers show the model millions of examples and let it discover the rules totally organically. It's a lot like a child absorbing language by hearing thousands of sentences in the real world, rather than sitting down and memorizing a thick grammar book first.
And because this underlying pattern recognition is just so incredibly versatile, it powers a massive landscape of tools you probably interact with every single day. It's not just text models drafting your emails anymore. It's image generators creating wild concept art from a single sentence, voice models revolutionizing audio, and even agentic AI automating really complex multi-step tasks for us.
Okay, but how do we actually build these models? It basically happens in three distinct stages. First up is pre-training. The model absorbs a massive slice of text, books, websites, articles, predicting the next word billions of times to absorb grammar and facts. But honestly, a raw model is a pretty terrible assistant. So step two is fine-tuning, where engineers curate helpful responses to teach it how to actually be useful to us. And finally, stage three is alignment, which involves extensive testing to reduce harmful outputs and ensure safety.
Right, so now that the model is built, let's jump back to your prompt. When you hit send, your text actually gets chopped up into these things called tokens. A token is really just a small chunk of text, roughly equivalent to a word or maybe a piece of a word. This is the fundamental way the AI digests human language.
So here is the rapid-fire magic happening behind the screen. First, your prompt becomes those tokens. Second, those tokens are converted into vectors. Think of these as coordinates on a giant map of meaning, literally turning words into numbers. Third, these numbers run through a neural network called a transformer, which weighs which words matter most to the overall context. Finally, the model predicts the single best next token, adds it to the sequence, and repeats the entire process. It is generating your answer completely fresh, one single token at a time.
Now, you might be wondering, if this technology is literally that advanced, why does AI sometimes confidently output completely incorrect information? We call this a hallucination.
Well, it all comes down to the mechanics. See, the AI lacks a built-in fact-checker. It's fundamentally optimizing for statistical plausibility, predicting what sounds the most plausible, not looking up verified facts in a database. If there are gaps in its training data, it just fills them in with its best guess. And if your prompt is even a little ambiguous, the chance of a made-up answer totally skyrockets. Remember, it's predicting, not knowing.
This brings us to a few really crucial takeaways to wrap up this explainer. First big misconception to bust, the idea that AI understands the world like a human does. It emphatically does not. AI simply recognizes patterns in data. It doesn't have beliefs, it doesn't have consciousness, and it certainly has no lived experience.
Moving on to our second takeaway, bigger always means better, right? Actually, scratch that. Not exactly. A model's intelligence relies heavily on data quality and that fine-tuning stage we discussed earlier. It's not just about raw size. Human curation is what makes a model truly smart. And here's our final misconception to clear up today. AI is not inherently neutral. Because it learns entirely from human-generated data, it naturally reflects whatever patterns and biases are present in that training data. This is exactly why ongoing alignment and human evaluation are such a critical, absolute must in the development process. Which leaves us with a pretty thought-provoking question to end on. If AI is simply an incredibly complex mirror, endlessly predicting the next token based on the massive amounts of data we have fed it, what does its output actually reveal about humanity's own digital footprint? Thank you so much for joining me to explore how AI actually works, and I'll leave you to ponder that.